and we are going to record the session, as you could hear already. It's nice to a lot of people entering the room now, entering the presentation. Okay, I think we're ready to start. Thank you everyone for joining for this webinar on circular electronics. So circular by design enabled by technology, which is part of the Tech and Spaces for Circular Economy project. And as mentioned, we are recording this presentation. So just so you know, we will follow this program. So some welcome words and some introduction to the project and why we're actually here and why we do organize this project and this webinar. And we are going to talk about the circular electronics change with one guest speaker. And we're also going to look into the solution to address these changes with two guest speakers as well, and conclude with a panel discussion where we will explore further and discuss around like some different angles that we started to see in the presentation and maybe we want to explore further. And some closing words where you will have also opportunity to ask questions directly to our speakers. So it's quite a program. We have 1 hour and a half, and it's going to be very interesting, in my opinion. So today I am Rémi Laoubi. I am the electronics sector lead at Circular Berlin. I have a background in engineering and physics quite some time ago, so I don't consider myself an engineer anymore, but I'm still very interested into technologies in general and circular economy specifically. And with me moderating this webinar, we have Stefan Aufrichter, who is the project manager on this project, also part of the education team at Circular Berlin. He's also a lecturer at the University of Applied Sciences at Potsdam, and he has a background in design and industrial design. So Stefan will be the one who can support you through the channel. You can also ask questions, any questions. We'll also post different links that we're going to share with you. And so feel free to ask him anything you have, any question you have regarding this session. And maybe before we start fully into like this presentation, maybe a warm-up question for all of us. Today, the European legislation imposes to have a collection rate of e-waste, of electronic waste, of 65%. That's the law. That's where we should be, all countries in the European Union. And would like to know what you think is or was the collection rate in Germany in 2021. So you should have a pop-up window in front of you opening. You have 3 options: 38.6%, 62.3%, or 75.1%. And we'll see the answer of this question in a few slides. So maybe before jumping into it, what is Circular Berlin? Circular Berlin is a non-profit organization which aim is to accelerate the transition of Berlin towards a circular economy. And it's a resilient and citizen-oriented region and movement where we are doing basically projects around the circular economy, but on education or knowledge building, which are open source, which can be replicable anywhere. But our focus today is on Berlin as an organization. We also have a community. So today we are like 140 people as community members. Anyone can join, actually. Anyone in the audience can join. You just can go to the website and register, and then you can have access to different resources, different presentation, different events organized like this one, for example, where we'll be also informed. As of today, we organized and we are being part or are being part of 19 projects, and we organize 50 events. And today we are in the frame of one specific project, the Tech and Space for Circular Economy. So why tech? Because tech has the potential through the domain of optics, photonics, and material sciences, which are the focus of the city of Berlin, to bring some new opportunities to facilitate the production, the reuse, the repair, or the recycling. But not only. Tech is not the only thing that we need. We also need space. We need space for promoting the innovation, to create room for cooperation and exchange, and it plays a huge role in a city. This project is sponsored by, basically funded by the Senatsverwaltung für Wirtschaft, Energie und Betriebe. So we'd like to thank them for this. And we are not doing this project alone. We are doing this with Vista and Creative Climate City. Vista is an organization running in part not only the scientific campus of Adlershof. So for people who are not from Berlin, it's a scientific campus a little bit outside of Berlin, with many companies and many research labs. Creative Climate Cities is an organization focusing to supporting the urban development, digitalization, and basically advising and supporting in the urban transformation processes. In this project, we have 3 steps. The first step is to collect the dots, meaning to map the ecosystem. So we ran last year an analysis around like use cases of how technologies and spaces can contribute to the circular economy. So we're going to, sorry for that, go to publish a guidebook. So sorry, it says in March, but we're already in April. So hopefully this needs to be updated. And we also have a phase of connecting the dots. So it's a series of workshops where they organize 2. The third one will be on electronics and will happen on the 15th of May in the afternoon. So we share with you a link right after. But we also have this phase of scaling the dots, which consists of a series of webinars, such as this one, where we basically talk about different solutions, different approaches, and also some knowledge exchange on what we learned so far. So this second workshop, or third workshop, depending on how we count, is going to be on the Thursday, 15th of May, from 2 p.m. to 5 p.m. You have the QR code, which you can scan here. Stefan is going to share a link in the chat. And it will be focused on co-creating repair strategies for Berlin. So please register. It's going to be very interesting. We're going to talk about all the aspects around how to enable the repair sector or how to support further the repair sector, from both product design to infrastructure. And now we had a question around like the collection rate. I can see the results. So most of you got the right answer. For 79% of people answering here answered the answer A, which is correct. So you are very educated already on the subject, showing that we have quite a challenge here, since even Germany, one of the most industrialized and most, let's say, rich countries in the European Union, is well below their own target set by the European Union. So we all understand that circular economy, as it was understood for a very long time, cannot just be thought in a way of like collecting waste, and we need different approaches and different solutions. But to best answer or best present us the challenges and some potential opportunities around the topic, I would like to invite our first speaker, Ronja Scholz, who is a circular design researcher at the Circular Design Lab at the Fraunhofer IZT. Ronja is also part of Circular Berlin in the education team and contributing also to this project. So thank you, Ronja, for being with us today. And I understand I'm going to share your presentation.
Yes, thank you, Remy, for the nice introduction. As already mentioned, I'm working at one of the Fraunhofer Institutes focused on electronics, and our department is the Environmental and Reliability Engineering Department. And so we do concrete development projects on more sustainable electronics together with clients from the industry, any kind, power electronics, but also consumer electronics. We also do, for example, politics consultancy. So we support the EU and the German government, often also in bringing up new regulations that can be implied, but also or implemented, but also really can advance the environmental friendliness, let's say, of electronics. So, for example, helping with the repairability index for France, we did, which may be one of the most prominent one. Of course, also eco-design regulation and implementation tools that will now be implemented in the, or is now going to be implemented in the ESPR regulation. So I still see the other screen, Remy. Could you find the...
Works?
Yes, now. And I was told to not giving the solutions yet, but rather only draw a picture of the current problems, the main important problems in the electronics sector, which of course then also are a big opportunity for circularity, because that's where like the gaps can be closed, let's say. And I may miss some. I try to draw a holistic picture. If I miss some, we have time in the panel discussion, I assume. And also, maybe we also see some solutions then afterwards. Next slide. So I oriented my presentation also along the value creation chain, which is valid for all kind of sectors. So you may be familiar with that system of the value creation. Then we use the value, and then in the circular economy, it's also really about the value retention, not throwing away what we did, what we used, but really trying to reuse products, then components, then materials only, and to keep the value as high as possible. But also in the value creation already, like try to bring in the idea of circularity by decreasing material consumption and resource consumption, of course, but also already thinking towards the end. So next slide. Some of the problems, I still see the old slide, I'm not sure, yeah. So some of the problems that we see currently in the value creation for electronics is obviously the resources. Everybody is aware that we use a lot of different critical raw materials that brings along a lot of social and environmental problems. And what many people, for example, don't know is, just to give you an example, in gold, in order to retrieve 1 gram of gold, nowadays, we need to like use 10 times the amount of stone and earth that we used 100 years ago. So in order to get that gram of gold out of the planet, we use 10 times the energy, 10 times the efforts, in order to still get pure materials. And that's true for many other resources. We will talk about batteries. So we know that there's a huge problem with lithium, and that means we have to figure how to use these raw materials better, and also how to reuse them. Then in the design phase for electronics, we have the highly integrated designs, which is great in order to reduce the resource consumption, of course, but it makes it really hard to repair, and that's valid for the board level as well as for the product level. Both are so integrated and often only thought towards the production process that you cannot access specific components or specific products in the product in order to repair them. Then we also have a lot of special components. And for example, in electronics, the ICs have a big footprint in the production process. And those ICs often are very specifically designed to the functionality. And there, then afterwards, you cannot really use them anymore. Where we see nowadays, there's this chip shortage, and it could be interesting to use maybe then 2 smaller ICs that are more general, and then you could reuse them afterwards. The production, of course, is very energy intense. So you need to have these like huge clean rooms that use a lot of energy. You need a lot of machinery, and also you have a lot of difficult consumables that used dangerous toxic gases, environmentally unfriendly gases. So that's big problems. And then, of course, for the logistics and transport, the entire global supply chain is extremely globalized also. So that means a lot of traffic of the products and the materials and the components. The next slide. Whereas in the use phase, that is obviously when the product that was designed has its highest value for the users, and then we have to make a little bit of a difference in between big and small consumer appliances, but also industrial applications. The problems are a little bit different, but maybe altogether we can say that there's for the use itself, there's the problem in, for example, on software obsolescence. That's what you see with any smartphone, where as we use all the apps that use a lot of storage, but also a lot of capacity, then they update all the time. And that means that the hardware that was perfectly working 2 years ago, all of a sudden, due to all the software requirements, becomes obsolete to some extent. And then there's also social obsolescence, which is kind of brought in there too, but also changing trends and changing requirements that often change way too fast, because there's just the newest gadget on the market and then you don't use the old gadget anymore. That's something that we see. Of course, there was a long time this energy efficiency delta that could be still increased, but with like any smaller gadgets, for example, or smaller appliances, that's not the case. There really the footprint is in the production. That means we need to prolong the use phase, and which is nowadays also true for the most of the home appliances from the large sector. Then the maintenance is a thing, like there is a little willingness, actually, I would say, and also little knowledge. So we work together with repair cafes, and one of the most popular products in there is the Senseo, and that's because it's rarely decalcified, and then the pumps go they break, and that would, like, just by decalcifying your product from time to time, that would already help. But as we have so many products, there is a lack of willingness and knowledge on how to actually do that. Then for repair, I have repair twice in this because you can consider repair as your self-repair, as a layman, let's say, or also as a professional service. So there generally, of course, the spare parts and availability and price are a problem. Then the design, as I already said, the products are not designed for repair, so it's really hard, which makes it also very cost intensive for professionals to do it. And then is also a little bit the willingness to repair if the spare parts are too expensive, if they take too much time often also, then people will consider rather buying new because they don't want to wait a week for a spare part, for example. And then for the reuse, that is for me when a product changes the user without any modification. There we have a big problem of liability because as most of us, we are not professionals. We can just not see whether something inside of the product is broken, which is different, for example, of course, for the secondhand market for furniture, where I can perfectly see the condition. And then the huge value decrease, which is similar as in cars nearly, due to the fact that there are all those changing trends. And then on the last aspect for all the our strategies for the value retention, next slide. There I already talked about repair. It's the same for the professional aspects. Then we have the opportunities to do remanufacturing or refurbishment. The difference is in remanufacturing, you just like restore the product to its functionality. You may replace some things. You will also look into how worn it is, whereas refurbishment really means on a large scale replacing components, for example. And there we work together with some producers. Actually, for electronics, I would say the best opportunity for the value retention is actually the remanufacturing and refurbishment, because it also means that it comes with like warranty from the producer. But then, of course, there, in order to know where your products currently are, in order to retrieve them, that's a huge effort to have the traceability in place, or it's just not done currently. And then if the company hasn't designed the products for refurbishment, for them, it's also cost incentive to use all the labor to refurbish the products and bring them back to market. Whereas if they did it, it's a little bit of a hen and egg problem. Let's say if they won't invest in doing it because they say it's not like the return is too small, but also if they don't design for it, like it will always stay the same. Repurposing is something that we actually look into now more also on the component level, because as I mentioned, the ICs, they have high value and there is the chip shortage. So why not using the ICs for lower need applications? Like IC from a early smartphone can still be totally used for smart home appliances, as Serda's thermostat, for example. There, of course, one of the big problems is knowing the condition that those products have been used in order to make sure that the functionality is still given and the longevity to the need, and also the logistics and the traceability, of course. Like if I knew I could use all the ICs of the Samsung A2 series maybe, or all the boards, that would be amazing. But knowing where all those Samsung A2 are currently is like a big problem as of now. And for the recycling, there's similar to design for repair. Design for recycling is not happening. We just launched a really cool design for recycling calculator in one of our projects, which helps the designers to already understand how connections, how the different components need to be designed in order to be actually recyclable according to the current standards, which means, for example, that ferrous metals have to be differently connected to non-ferrous metals, because otherwise the non-ferrous metals would end up in the ferrous stream and then they can't be retrieved. But also many recycling processes are not in place. In electronics, we talk about like milligrams of or traces of some of the materials, and for those, there you often is not yet a not yet a recycling process, and it's also questionable whether it will ever be viable on the large scale, because tracing back these milligrams of various materials in a big product, it's kind of impossible. And that's not electronics, but I once was told that a lot of titanium, for example, is used in our wall paintings to make the walls brighter white. Well, how would you ever retrieve this titanium out of the color of the walls? That's something that's like technically nearly impossible. So the same applies for a lot of scarce materials. And there, for example, I would say we could consider, there is I forgot which material it is, but there, only to make our phones vibrate, for example, we use one specific element, and we could really discuss whether we need that, if we could also go without this specific element and then don't have to invent machinery to retrieve it back. And on that, where I would also like to add here, which is in pink on the left, is also a lot of regulatory and legal aspects. Because, for example, currently there is this waste export rule that you cannot ship whatever is considered waste as across borders. And anything that me or you as consumers declare waste, although we don't know anything about the condition, needs to be considered waste. And we know that every fifth washing machine ending up in the collection actually is perfectly working. It's just not used anymore. And so then we declared waste, it needs to be traded as waste, and it can't even be shipped towards another processing in a different country. That is one of the big problems. Then the liability and warranty. So whenever something is refurbished, whenever something is remanufactured, who will keep the liability? As I said, you don't really know of the condition. And that's one of the biggest problem of, for example, like Rebuy, all these companies offering already secondhand products, that they monitor the condition and they think the product works well, but then they still have a lot of returns because they couldn't identify one of the problems that then appears quite quickly after the sales. And of course, also taxes, for example, is a big problem, because why do I have to pay full taxes on a refurbished or remanufactured product, whereas the value creation has already happened in the first sales? So that is one of the problems. And I would say that it's not necessarily to change all these regulations, but any service or like any offer that could help to cover these, for example, traceability, condition monitoring, they can really have also a big impact on how this can be solved. And then I know I'm out of time, but I will give you one very quick last idea, because many people are still like very driven by this idea of technology will solve it all, and I'm also working partly on that. However, like we often say this, like green bioelectronics, we will invent the sensors to trace all this back, and to improve reverse logistics, improve predictive maintenance, for example, improve energy efficiency. I think that's a great idea and we should use it. However, currently, as we've seen, the system hasn't changed yet. We often face problems like rebound effects, that higher availability or like scaling of some of the technologies increases the access and the availability because it decreases the price, and then it brings like the surplus in the market, let's say. And then there are other side effects. So I think when we want to use electronics to actually apply them for improving the supply chains, we have to be very careful. And to give you one number, I just read a study on the potential effects of AI on e-waste, and they calculated, because AI may have the problem that they want to use better hardware all the time because they have so high calculation capacities, that in the end it has the potential to increase the waste stream by the factor 10. And already now it's meant to be doubled in the next 25 years, but by increasing it by factor 10, that would be we can't handle that anyway. So considering that we will use AI, and currently we have the energy efficiency problem anyways, but also thinking of how we can then improve the hardware towards the learning with the AI, let's say, that could be would be one of these aspects we really have to keep in mind. And with this, I hope.
Yes, thank you, Ronya. I think it was very interesting. Thank you for the broad picture that you gave us here, that you painted. And to answer some of these challenges, I'm now going to welcome Daniela Colin, who I will actually let her share a screen directly.
I will try.
So Daniela is a team leader at the Fraunhofer ESC, sorry, in the Department of Center Smart Material and Adaptive Systems. And you've been working on a big European project with a consortium of different research institute, and beyond that, also different stakeholders from the industry. So we're very, very excited to hear about your work. I will let you introduce it, and yeah, thank you very much.
Thank you for the nice introduction, Remy. Thank you very much. Thank you, everybody who's trying to listen to my talk right now. I will try not to dive too deep into the chemical aspects because for my background, I'm a chemist. I try to keep on the detail level to keep everybody interested in the talk. So it is, as Remy already said, a talk about one of our current project. It's about circular economy applied to electronic PCBs based on paper to create the circularity on that. Yeah, just as a first question for the first slides, why do we think that paper-based electronics could be a solution for current challenges? So we already had these numbers or slightly different numbers. We have the issue with the electronic waste. We have to recover and recycle it, and the rates do not meet the targets that we have on the political regulation. I think Remy showed a number of 65%. So worldwide, we are far away from these targets, and even in Europe, we are far away with a little bit more than 40%. And as we just learned in Germany during the last years, we were slightly below that. So we see during the last years that the recovery rate is increasing, but the recycling often concentrates only on specific materials and valuable metals, for example. So the question is so I have to move all of the images of us to the side so that I can see my slides. So if you think about electronics and printed circuit boards, which are all made of FR4, so we don't only have the components, but also the substrates. So the substrate itself is hard to recycle. So that we thought an alternative material could be paper. And using paper as a main component of the electronic that could generate some interesting perspectives. So for paper, there is a efficient recycling process throughout the world. If we combine the e-waste recycling and the waste paper recycling, we think that we could gain an increased user acceptance because we are already collecting a lot of different waste, and if we increase the number of waste bins, everybody has to sort it out. This will not increase in acceptance by the users, but if we can combine it with something which is already accepted, that could be a win situation. And if you think of paper as a substrate, also upscale processing like roll-to-roll manufacturing could be applied. So at the beginning, we thought that printed electronics on paper has to become more or has already become more and more technologically mature. So we have still some major gap between FR4, of course, which is standard, and paper electronics. But they find their application, for example, in smart packaging, smart labels, wall-to-wall printed electronics. And at the moment, these, as I said before, these paper electronics use simple electronic circuits, mainly to the technical constraints which a paper by its nature brings with it. So we thought that if we use paper-based electronics, could that in general replace conventional electronics? And in case we want to succeed, there are a series of technical challenges that has to be addressed. So on the one side, it's about the complexity. So we need a high integration density, which is the number of components of circuit lines, etc., per area or per volume, because at the standard multi-layer PCBs are used if you use a multi-layer, we have to distribute the wiring on different levels, and we will have to do that on paper as well. And also the vias or the vertical interconnections, which is for the multi-layer FR4 PCBs standard, has to be developed for paper as well. So this is which is contributed to complexity and performance. Then we have paper as a subset, which in the middle you can see the stability is a very important factor, because this is some of the excellent properties of the FR4, which just has not been met yet by the paper. So the paper properties are not to change during the usage. So we have to define humidities and temperature ranges where the paper has to be stable, and of course fire resistant. So these will be the focus of the paper development. And then if we say we want to use paper because of the recyclability, the modification of all the new materials has to be without the reduction of the recycling properties itself. So every addition of new materials and process steps has to be considered with respect to recyclability. So then we created some kind of a project idea, sorry, about this circularity, or circular economy applied to electronic printed circuit boards based on paper. I have to drink something. So yes, I've been 6 weeks ago. So let's give it another try. So we want to start with renewable sources and create functional bio-based materials to create the PCBs. And then we want to create these electronics, and then on the technosphere use the circular principles to regain the paper on the one side, and the functional raw materials on the other side. So we want to develop different circularities. And so the biosphere, the technosphere, and also use materials which are harmless for the ecosystems. I really apologize. So we already heard the strategies of the circular economy. We think that we can contribute to different R's. So on the one side, we think electronics, use the additive processes where possible, and galvanic processes if you need higher conductivity, and we want to create the vias in the paper, and then on the reuse and the recyclability to reuse the cellulosic fibers on the one side, but also components, metals and polymers, and for the recycling recyclability, improve the paper recycling processes to reuse the rejects or the components and the metals. And then finally, I want to give some concrete examples of the R&D activities we have in this circuit paper project, which is now in the third year. So we developed a new electronic paper with our partners, which already uses like 80% of recycled fibers from previous usages. We created flame retardancy by an impregnation step with sustainable additives and are currently investigating the influence on recyclability. Then we have a lot of work on sustainable materials. On the one side, on the metal inks, because they are some of the valuable materials. So we are using silver, which comes from recycled resources. Looking for alternatives like alternative metals, which are less harmful, like zinc and tin, which can also come from secondary sources to close the circularity loop here. And we have a lot of work on bio-based materials, additives like solvents, binders, dielectrics, which is mainly our part in this project. And then we try to create demonstrators to show the processability and then the performance. You can see it on the top, some very early demonstrators, mainly on one-sided papers, but we already realized 2 layers and laminated demonstrators, and now want to increase the complexity. We also demonstrated that when we increase the stability of the paper, that also the harsh conditions of electroplating and standard PCB processes can be met. So if you need higher conductivity, we can use electroplating. Or the usage of printed seed layers and copper laminates, also to create a little bit more performance on that. And this is all accompanied by a partner who's looking at the recyclability of the paper and of the materials. And one partner is looking at all the LCA analysis, looking at the comparability of our process to be comparable with energy costs, with the material costs, and all the global warmings, for example. So I'm sorry, I hope you can understand me. As a conclusion, we think that paper can be a relevant material to solve or contribute to the solution of the e-waste problem. Technical challenges are there. They have to be solved to be competitive against conventional electronics. We think that we can contribute here. And we demonstrated that techniques from printed electronics can be employed whenever useful, and also to accelerate the process speed by wall-to-wall processes. And the recycling and pulping process, when we think of the circularity, they will have to be adapted to regain the non-paper material. So this will be where we have to meet with all the recycling companies to get their willingness to adapt their street lines and everything. Yes, and here just a short overlook of our project. We are 9 partners from Europe. We are now in the final year, and I think that we are doing great work here to learn a lot about paper electronics. And I thank you for your attention. Sorry.
Thank you very much, Daniela, and thank you for managing to finish your presentation despite your
somehow at least
strong allergies, or I don't know exactly. Yeah, thank you very much. I think it was very interesting. And without further ado, I'm going to introduce Maxime Bleskin, who is the CEO and the co-founder of Voltaire. Voltaire is a company involved in the remanufacturing of batteries, and Maxime is founded this very I would say, inspiring company. So I'm very happy to have you, Maxime, to speak and give us like some perspective onto this. And I'm trying to share my screen.
Hello, everyone. Can you hear me?
Yes, perfect.
Okay, hello. It's a pleasure to be with you today. And I would like to thank you, Circular Berlin, for the invitation and the opportunity. So I just realized 10 minutes ago that we have probably been using the wrong word all the way long. Because if I refer to Ronia's presentation, it would be more appropriate to speak of repurposing rather than remanufacturing. So thank you, Ronia, for clearing that out for me. But being more serious, I will focus on the second life through remanufacturing or repurposing. Anyway, the wording is not so important. And I'll be sharing how this approach can actively contribute to building a circular battery economy in Europe, one that is local, that is efficient and resilient. If you can switch, please, Remy, to the next slides. So if we start with the big picture, by 2030, 3 billion lithium batteries will be circulating in Europe, approximately. And that number is growing super fast. But with this growth comes a significant environmental cost, because producing just 1 kilogram of batteries generates approximately 32 kilograms of CO2. So batteries are essential to electrification. They are essential to decarbonization, but they are also resource intensive. And this is why we urgently need to rethink how we manage this entire life cycle. If you can switch to the next slide, please. So what is wrong with the situation today? Today, 90% of the batteries placed on the European market are manufactured beyond our borders. And yet, when they are sent for recycling, they often still hold up to 80% of their initial capacity. That means we are discarding huge amounts of embedded energy and critical materials and economic value. And this isn't just an environmental issue. It's also about energy sovereignty and industrial resilience, because we need, especially in the current context, to build a strong economy and a resilient economy. So instead of treating these batteries as wastes, the idea is to consider them as a resource. What I'd like to say is that the world's largest lithium deposit is in Europe, but it is not in our soil, it is in our pockets, it is in our smartphones, it is in our laptops, it is in our cars, but we have the resources right under our noses. If you can switch to the next slide, please. So what is our approach? Obviously, turning those constraints into solutions. At Voltaire, we focus on remanufacturing or repurposing, which is the step right before recycling. That means we recover the most valuable and impactful part of the battery, which is the cells. Why is that important? Because the cells represent around 80% of the total environmental footprint of the battery, and also about 70 to 80% of its production costs. By identifying and reusing healthy cells, we preserve most of this embedded value, both an ecological and economical. Here, how it works. So we collect end-of-life batteries from manufacturers, from retailers, recycling organizations. We dismantle them to extract the usable cells. Each cell is going through a diagnostic and a prognostic process to assess its state of health, which is its residual value, and estimate its future lifespan. And finally, we reassemble new battery packs, combining second life cells with new components, such as BMS, which is the electronic cards that rule the whole system, such as casings and connectors. And the result is a battery that performs just like a new one, but with a dramatically lower environmental impact. Switching to the next slide, please. So coming back on the value proposition that lies beneath all of this, our remanufactured batteries have a high performance standards. They meet the industry standards in terms of power and in terms of reliability. They are cost competitive because we don't have to buy the cells that represent 70 to 80% of the production costs, overall production cost of a battery. So our batteries are cheaper than new batteries. They are certified and guaranteed, which is key to the economy, because otherwise we wouldn't be able to sell it to big industrial firms. And this is aligned with European and US regulations. And finally, they are eco-designed for minimal impact and maximum reuse, obviously. And we like to say that we aim to combine technical excellence with environmental responsibility. So if I focus on our life cycle assessment that we have been conducted with a professional company earlier this year, it shows that our battery reduce carbon emissions by up to 80%, 86% compared to a linear battery, I would say. They use 6 times less energy, they require 26 times less water, and they need 6 times fewer mineral resources like lithium that we all speak about, or cobalt, or graphite, or anyway. All of this is possible because we reuse the existing components instead of extracting and producing everything from scratch. Next slide, please, Remy. But remanufacturing is not just about making better battery, it's also about rebuilding the system around them. And there are still key barriers to overcome the whole process. First, we need to access to technical data, such as the BMS info or cycle history, or such as the sales data sheets, because it is key to ensure certification afterwards. And this is very difficult for us. Second, we need to build market trust, especially in demanding applications. And even if our technology and our products are as performant as new ones, there is a lot of things to be done in order to reassure our clients. And the last barrier is the lack of clear industrial standards for second life products. And just even the terminology is not that clear, because if you're in France, you won't be speaking about repurposing, you will be speaking about remanufacturing. Yes, if you're in Germany, you will be speaking about repurposing. And all of this carries out different regulations, different norms, different standards, and this is difficult for industrialization. So to succeed and to overcome all those barriers, what we need is obviously a better policy alignment, especially on the end-of-life frameworks overall Europe. We need a cross-sector industrial cooperations from the OEMs to the recyclers, because we are not all alone on our islands. And what has been shown on the other presentations, on Daniela's and Ronja's presentation, is that a circular economy is a whole system, and we need to build the whole system together and not each part separately. And obviously, what we need is investment in modular and scalable infrastructure, because We do have an innovative industry in Europe, which is quite in advance compared to the rest of the world. Sorry, but we need to maintain this position, and to do that, we need to scale. And scale is capex intensive, so we need investment to scale. And because circularity isn't just about reducing waste, it's about creating value, locally building resilience, and ensuring resource sovereignty. We need to put the means in front of all these challenges. And next and final slide, please, Remy. To conclude, at Voltaire, we believe that Second Life doesn't mean second class. This is really important, and we need to make this a belief shared by everyone through Europe. And with the right technologies, with the right data, with the right partners, we can turn used batteries into high quality, sustainable products and contribute meaningfully to the European circular economy. That's it. Thank you very much for your attention.
Thank you. Thank you, Maxime, for sharing your experience and what you do at Volta. It's very interesting. I'm just going to reshare my own slide. Give me 1 second. And so the next is to lost again between all the different tools, but you get the point. Next is to have all of our speakers that shared with us their knowledge already, to welcome them to the panel and to engage in the discussion. So thank you very much. Maybe since we just finished by Maxime's presentation, and I had one question which came to my mind regarding your potential challenges and maybe how you solve it from your side, is I would imagine that you have a lot of diversity of type of used batteries coming to use, potentially from different manufacturers or different providers. How do you handle this diversity? I guess like the big difference that we see with like the linear economy is we have one standard products which always come qualified, but you get like some kind of material which is very different from one cell, which is very different from one another. How do you handle this diversity? How do you make sure like you can somehow standardize in a way the remanufacturing?
Yeah, well, that's an excellent question. So thank you for asking it. So you're right. One of the key challenge for circular economy is diversity or viability. So there's no miracle solution. What you need to do is work on two aspects of your process. The first one is the versatility of your production tools. And this is part of the innovation, the technological innovation that you need to put in place. And this is what we've been doing at Voltaire for 3 years now. The second aspect is you need to work on your upstream sourcing. Because there's all this variability, you need to choose carefully, and you need to first you need to map the whole stock of used batteries that is available for collection, and then you need to focus on one or several sweet spots, I would say, that are easier for you to industrialize. So this is what we've been doing. The second part of the answer is that you have a lot of diversity among batteries. This is true, but when it comes to cells, it is very much less true, because I don't know if you can see my camera, but I'm showing a prism cylindrical cell. This is called an 1860 650. So in French, 18650. Those are the measures of the cell, and this represents about 90% of what we treat at Voltaire's. So the aspect of our process that is really that really needs to be versatile is the first part of the process, the one when we need to dismantle the batteries, because the second part is much more standardized, I would say.
Okay. Okay, very interesting. Thank you. So maybe an open question to everyone. What do you see today as the main change that you see across like the electronic product industry? So I include batteries because I feel like batteries also play a big role into like our connected devices of today. So what do you see as the main maybe opportunity, maybe like the main hurdle that you can imagine at the moment? Hopefully positive, but I'm curious to hear what each of you thinks as the main impact today. And maybe we can start with Ronia, who showed us like the overview already, and if you want to share your opinion here.
I mean, as Maxime also just said it, to me, to some extent, it's not the hurdle, but the opportunity kind of is pushing by regulation, because regulation is also what represents our society more holistically. And yeah, I don't see, if you follow presentations from Intel, for example, on how they want to increase their production like quadruple within the next 10 years, and you're like, oh wait, we have like a big climate problem here that's already now a problem. How is that if we quadruple production in plastic sector, in electronic sector? Like, how can companies still think that way to some extent as a person of the society living on the planet? I always wonder. And not so much as the scientists, let's say. And so I was just, as you talked about the batteries, the UK government made a calculation that like in the single-use vapes, in 6 single-use vapes, you have the equivalent of lithium that you could use for one iPhone. And on a global scale, we have in single-use vapes the lithium that we could use to produce 11,000 e-cars, like electric cars. So for me, it's like we ban single-use straws, but we don't ban single-use electronics. Why don't we do that? And why don't we, or like at least have a reclaim system, a deposit system on these things? And there, I think regulation is sometimes still too slow to figure out how fast the industry changes, and also to enable better investments in these. Like, as you said, it's CapEx intensive. You need research. You need investments for the better, but that's currently really not encouraged. And so for us as a society, I think the changing the rules really would be one of the fastest means.
Okay, thank you. Daniela, do you want to share your point of view and maybe complete also what Ronia said, or bounce back on what Ronia said?
So I totally see the points that Ronia already said, which are the challenges. What I kind of sense during the last years as a research institute is that the awareness that there are these challenges and these issues arises. So if you talk to companies doing the electronics or parts of that, the e-waste issue is always there, and there's a lot more possibility to talk to people from these companies to look for new solutions. So there are different levels of reducing or e-waste or energy costs or something. Some are easier for them to set, and for us as a material research institute, we are quite further away from the TRL levels that they are working with. But I think that that the awareness that something has to be changed is growing.
Okay. Thank you.
Yeah, if I can give an answer to your question as well. Well, I think to state the obvious that what is currently happening on the other side of the Atlantic Ocean is a turning point because it's the opportunity for Europe to make very, very important and decisive decisions, whether we want to maintain the direction towards circularity and all what that carries, or whether we want to follow what the United States are choosing as a new path. But I think this is an opportunity because of all those measures that are announced each and every day. We need to make some big changes in the European industry, and I think that big decisions come with crisis. The history has shown that, and this is a crisis. So we are this is the good moment to make big decisions. So this is the first part of my answer. And the second one, focusing on the battery economy and sector, in terms of regulation, there has been quite important changes recently. We've adopted the European battery regulation in 2023, which introduces for the first time the regulatory frame for all that is circular economy, really. So in France, for instance, the consequence of this is that before we didn't have objectives for remanufacturing, repurposing, and whatsoever. It was all the battery waste were directed to recycling. But now we have a stream that is comment dire, réservé, that is sorry, I don't have the English term, but which is for repurposing. And this is very important because without the waste, you can't do a circular economy. Access to waste is key for industrial. And now we have access to waste, and this is bound to regulation. So this is good news.
Okay, that's actually very interesting because I think, Ronia, you mentioned something similar in a way, the way legislation, regulation, I guess you took I don't know if you were talking more about Europe or Germany, how very fast, very soon, it's categorized as waste and regulation around that are very tight for also avoiding some negative effects of like exporting waste to countries where they are not handled properly. Roya, maybe do you see the same, that what Maxime said around like this access to waste or access to end-of-life products, a key aspect of how the regulation should be also arranged for like enabling the circular economy? Do you see this as a potential lever or barriers or blocker to lift?
I mean, yeah, I think for me, regulation should try to not be too normative, but rather like leave the corridor for different solutions. So, yeah, that's what sometimes can also be tricky. And then also there have to be always the solution. Like to give you a good example, we supported Fairphone on their development, and before Fairphone, all the phone companies would say like, well, a waterproof a phone that also has an exchangeable battery, it's impossible. So we can't do it. You can't do any regulation about that. And then all of a sudden there was a new player on the table, and they were just in the same conversations, and they said like, well, we proved it's possible. The question is whether you want to regulate towards that. And that was really cool, because all of a sudden the arguments of the big players were gone, and now it's the question whether the EU follows or not, right? But you have to kind of convince the policymakers first of all, always to that it's possible to some extent. Until then, the big players in the field will try to protect what they are doing, unless they already have a good solution. They see the business opportunity in there. So then they may also want to have a level playing field, let's say, to get there. So yeah, it's tricky, but still I think we should foster faster how this can be changed.
Okay.
Yeah.
Okay,
I would have a
interesting.
question to Maxime.
Please go
if I
ahead.
may. So, for example, thinking of these e-waves, like if there was a deficit on it, or if you could rebuy them, can you figure, like, because it's still quite small amounts, but in some it's quite a lot. But I don't know, like I'm not a smoker, so I didn't know they are quite expensive. But I was wondering if you could say out at top of your head, like what would be the price you could give people, and whether that would be interesting for them to hand it back to you to some extent.
Okay, so that's a good question again. Well, to be fair and to be transparent, our business model relies on the fact, part of our business model relies on the fact that today, as of today, we don't pay to access wastes. It's the other way around. Because battery waste is something that it's a pain in the ass, because it's sorry for the expression, but it's dangerous. Everybody knows that it can cause fire, and so it's a liability in terms of insurance, in terms of infrastructure. It has great consequences for the industrials. So we charge for the service that we provide to take those batteries and to deal with them. But so this is the first part of the question. The second part of the question is we've been looking into this specific type of batteries, and we proved that we can give them a second life, and it can be how would I say that it can be profitable. Sorry, even if we were to buy those batteries. So I can't say the exact figure, but we could spend some money in the acquisition of the batteries, the wastes, and still be profitable. But the market state as of today is so that we can charge for something, so we are not going to pay for something that we can charge. This is the answer. But it's a very good example, and you said the key thing in all of this for me, and you said it, is that we don't need single-use cigarettes. I mean, this is a nonsense. So we need to ban them, and this is like the best option to adopt, in my opinion.
Yeah, for me it's interesting, but because I saw the question, we can move on. But that's one of the pain points of these circular business models, which we call gap exploiter, because you then exploit something that's currently not used, but as soon as it becomes value, that might be tricky for you. On the other hand, what people don't know, in Germany currently every week one of the trash collection cars is burning due to these e-waves not being disposed correctly, which costs a lot to the companies. So then sometimes for me, in circularity, it's also the question, like, who has the leverage and who has the incentives to then reduce this? And I mean, already, if we can't ban them, giving a deposit on them would help a lot. But this, like, even the trash collection system should have an interest in solving that problem, and may have even a better lever to push policies towards it than you as one company. So yeah.
So one.
And that's a, sorry, if I can just
go on, please.
Reply now. You tell me if you want to move on.
No, I think it's interesting.
Okay, but just to, I think it's interesting because it's a good link with the previous question. What we have in Europe is the extended responsibility of the producer, if I translate it from French. And this is a key principle, because what it means is that the one that has to take care for the costs of the end of life treatment of a product is the one that puts this product on the market in the first place. And this is key because at the end of the day, it doesn't matter if the waste has value or doesn't have value. There's the people that put those products on the market, they need to finance what is going to happen at the end of the first life of the product. And this is a very powerful tool that Europe has introduced. Now we need to shape the whole system, and that is not quite finished, but this is a very important tool and very powerful tool, in my opinion.
Interesting. So thank you. I also have many questions for all of you, but maybe Daniela, since Ronia and Maxime also gave you a break from speaking and recovering your voice, maybe I was wondering, from your point of view, how do you, because Ronia said, okay, she took the example of Fairphone and how big industries would say, hey, we don't have the technical solution, so please don't put a regulation, otherwise it's going to be difficult for us. And how actually, when solutions are available or are proven available, then it can be a game changer. And I feel like what you do and your work is exactly at this center by developing this new type of solution. But it requires, as you mentioned, consortium to have like multiple stakeholders involved. How would you say, how do you make the best of such consortium? How do you create the right synergy and the right dynamic so you really move from the problem to starting to having solutions available that can be then industrialized? Could you share with us your experience here, like how you make it the right way?
Yeah, that's a good question, and this is constantly in all of our thoughts, because a good and a suitable consortium is key to success at this point of development. Because as I said before, we are working on materials, sustainable materials, and new materials, and here we are often. We look at the application, we have that in mind. We also have the processes here at the Institute at hand to demonstrate the feasibility, and that it's not like university stuff, which is quite nice, but it's not applicable. But to have the right partners at hand is key to have them the opportunity to bring them to life, let's say, after the project. So we do have a lot of partners, also other institutes, but also companies which have a long-term or mid-term, let's say, collaboration. And we always win if they also bring companies with us, with them, or we find companies which are willing to later on go into the investment of changing something, because this in general is always some of the outcome. You have to change something, right, either the processes or the materials or whatever. And this is also a little bit in parallel to all the regulations. If there's no need to change something, nobody wants to change anything at all. And here, I think it's always good to have a very enthusiastic consortium to bring something to success in the end. And at least for this consortium here, we have really some eager companies on the paper level, on the metals, for example, which are looking forward in commercialization. Yes,
Okay.
so and that's
Very, yeah.
satisfying also for us who wants to bring something new on the way.
Yeah, it's very interesting. Very interesting. And yeah, I guess like you need to have the what I noted is you need to have the two in parallel, like the technical development, but also start to formalize some regulations. So we push the rest of the industry, but then you also need first adopters for this type of solutions.
Totally. So I completely agree with Vanya that a lot of companies, a lot of industries, they have their, let's say, if you stay in the context of sustainability, they have some sustainable solutions in their desk, in their shelves, in their whatever. They don't share it until they have to. So some years ago we had also it was more on packaging, not for electronics, but for completely different for food, for example, for coffee cups and stuff like that. Everybody was eager to have it like sustainable. Nobody wanted to apply that because it's more expensive or something. And you had the better urge, and once in a sudden, everybody had some kind of a solution of a paper-based coffee cup or whatever. Like so. Beforehand, you could go to any kind of company and they would say there's no interest in doing something sustainable, bio-based, biodegradable, or whatever. But once it had to be, and there were a bigger urge, then suddenly everybody had a solution at hand.
Sure.
Somehow, at least.
Okay, Stefan, maybe there is one or we have time maybe for one or two questions from the audience.
We have one from Ralf Ehrlich to Daniela. It's more 3 questions in one. So the first one is, what are the typical applications you are targeting with paper-based electronics?
That's a good question. So as we're looking for new solutions, the TRL level is quite low. I already said that several times. And we want to rather demonstrate the feasibility than go for a direct application, because we don't have manufacturing at the moment, which could go for a real application. We have the demonstrators in the sector of medical application, like a glucose sensor. We have in logistics a time and temperature logger, which can be realized by our technology, as well as for the consumer electronics and paper-based loudspeakers, for example. So, but the reason for that is mainly due to the consortium. This we can realize by ourselves. It's not the end of what can be reached, but what we can demonstrate. We have also an advisory board member, which is quite interested in this application, also for low performance, let's say, application. But this should not be the end. But actually, as we are now coming to a level in the project where everything comes to an end, let's say, now we can better, I think, start to think about the final application. So this will take some more time to really answer it.
Thank you. The second one, sorry, is about the recycling streams. These applications will end up in the same streams with all VEE. Depending on the applications, take back of products might be a better way to get these resources back.
Yes, we are discussing this as well. So the original idea was to get everything in the paper recycling streams to at least regain the paper, but then of course we dilute all the metals and all the components. So there might be the need for an individual paper electronics recycling stream, maybe. Or yeah, as the suggestion is, looking for a direct collection stream. So I think we are not up to decide that in the end, but to prove that the recyclability is there, and then there should be new discussions, let's there.
Okay.
Mhm.
Thank
The
you.
higher
And
value lies with, for certain within the metals and not in the
Yeah.
paper.
Yes. Yes, of course. So we did some really good experiments where we regained like nearly 90 or 95% of the silver of the sample. So
Nice.
it was quite feasible. So let's see.
great. And the last one is about the life cycle assessment. Did you compare the applications with FR4 and paper PCBs?
We plan to do this. We did not do this until now because we don't have the final, let's say, constitution of the new developed materials at hand. But we will do that in the coming couple of months because we now at the fixing, like the finalization of all the materials, and then we can start to look into the comparison. But we definitely want to do this. Yes.
Okay, great. Thank you.
Yeah, thank you very much to everyone. I think I realized, Maxime, I forgot the E at the end of your last name, so sorry about that.
No
I think
worries.
I think it was a very interesting panel and very interesting discussions. So I would like to thank you, Ronia, Daniela, and Maxime for participating and sharing your point of view. I guess there is chances for more discussions, but we also have to respect the time as we are all also trying to change the society and get out there. But there will be another opportunity to discuss and mostly focus on maybe repair strategies. As I mentioned already, so we have the second workshop coming on the Thursday, 15th of May from 2 p.m. to 5 p.m. Here you have a QR code if you want to register on Eventbrite. So if you want to keep changing the world to make it a better place, then please join us. And in the meantime, I would like to thank everyone for their participation, from the speakers to the audience to the team supporting here to make this webinar a success. And I wish you a very good day.
Thank you. Have a good
Thank you
day.
too. Bye.
Thank
Bye.
you.